This video is going to go through the definitions of empirical formula, molecular formula, structural formula, and then I'm going to go through a worked example to show you how all three of these are linked together. Okay, so the empirical formula is defined as the simplest ratio of atoms of each element present in a compound. The molecular formula is the actual number of atoms of each element present in one molecule of the compound. For example, if we have the compound C2H4, the molecular formula is C2H4 because that's the actual number of atoms of each element in one molecule of that compound. But the empirical formula will be the simplest ratio, so what whole number will divide into both 2 and 4? So the answer to that is 2, and then that would give us the empirical formula as CH2. So the molecular formula is a multiple of the empirical formula, where the multiple, denoted by the letter n, is always going to be an integer. So we don't have to have compounds that contain just carbon and hydrogen. Let's say we had carbon, hydrogen and oxygen. First example, where the molecular formula is C2H4O2. So what integer would divide into both 2 and 4? So the answer here is 2, and that would give us the empirical formula CH2O, where n, the multiple, is 2. And again, if we have the molecular formula as C3H6O3, what number divides into both 3 and 6? So here the answer is 3, to give us CH2O, where the multiple n is 3. So both of these compounds have the same empirical formula, but different molecular formulas. So the structural formula shows us the sequence in which all of the atoms in a molecule are bonded. For example, if we have the compound C3H8, the structural formula shows us the order in which these 3 carbons and 8 hydrogen atoms are bonded together. Okay, so now if we go through a worked example, let's say we're told that the percentage composition of this unknown compound has 52.2% carbon, 13% hydrogen and 34.8% oxygen, and that its molar mass, Mr, is 46 grams per mole. So the question is to find what the molecular formula of this compound is, and then to suggest a structural formula. So if we say we had 100 grams of this compound, then the percentage compositions can then be expressed in grams. So we have, out of that 100 grams, we have 52.2 grams of carbon, 13 grams of hydrogen and 34.8 grams of oxygen. So those three numbers add up to 100. What we do next is divide by the atomic numbers, which you can find from the periodic table. So 52.2 divided by the atomic number of carbon, which is 12, then 13 divided by the atomic number of hydrogen, which is 1, and 34.8 divided by the atomic number of oxygen, which is 16, and we get these numbers. So from there, to work out what the ratio is, we then divide by the smallest of these 3 numbers. In this case it's 2.18. So 4.35 divided by 2.18, 13 divided by 2.18, and 2.18 divided by 2.18. And here we get the ratio of carbon to hydrogen to oxygen to be 2 to 6 to 1. So that tells us that the empirical formula is C2H6O. So remember, the molecular formula is a multiple of the empirical formula. So we know that n is the multiple, and that has to be a whole number. And so n times C2H6O will be equal to 46 grams per mole. So the calculation goes like this. So in the brackets we have 2 carbon atoms, so 2 times the atomic number of carbon, plus 6 times the atomic number of hydrogen, plus 1 times the atomic number of oxygen, and all of that is multiplied by n to give 46. So we get the atomic numbers from the periodic table like before. So 2 times 12 plus 6 times 1 plus 1 times 16. So that gives us 46 times n. So 46n equals 46. So n is equal to 1. And so the molecular formula is C2H6O, which is the same as the empirical formula. So suggest a possible structure for this compound, and so that's one possible structure to give ethanol. So in summary then, when we're given the percentage composition of a compound, it doesn't matter what elements are present. It could be just carbon and hydrogen, or carbon, hydrogen, oxygen. It doesn't matter what elements are present. From those percentages, we can work out what the empirical formula is. Remember, the simplest ratio of atoms of each element present in the compound. And then if we know the molar mass from that, we can then work out what the molecular formula is, and then finally we can suggest a structural formula.